Hi everyone, I'm Cheryl. In this problem, we're asked to use spherical coordinates to find the volume of the solid generated by looking inside the sphere x squared plus y squared plus z squared equals 9, outside the cone z equals the square root of the quantity x squared plus y squared, and we're above the xy plane. So first of all, let's get a sketch to see what I'm looking at. I have a sphere of radius 3. So I'm just going to draw the top half of that sphere because I also know that my solid has to be completely above the xy plane. So it's really a hemisphere that I'm looking at initially. Okay. But I also know that I have a cone that's going through the origin. So what I'm looking for is the solid that's created inside that sphere, but outside of the cone. So to find the volume of this solid, I'm asked to use spherical coordinates. So I notice that my sphere, x squared plus y squared plus z squared equals 9, can be written as rho squared equals 9, or in other words, rho equals 3 in this case, because again, I know that it's all above the xy plane. Another thing I'm going to want to do is find the intersection. Where does that cone intersect with my sphere? So let's go ahead and take a look at that sphere. And I'm going to write it as x squared plus y squared plus z squared equals 9. And then I'm going to notice that if I group the x squared plus y squared, I can replace that with a z squared from my cone. So I have z squared plus z squared equals 9. 2z squared equals 9. Z squared is going to be 9 halves. And so z is going to be plus or minus 3 all over the square root of 2. But remember, because I'm all above the xy plane, I only want the positive 3 over root 2 version. Okay, that's great, but I'm not using spherical coordinates. So I know that using spherical coordinates, that z is equal to rho times the cosine of phi. So in this case, 3 over the square root of 2 is going to equal rho, which I know is 3 because it's on my sphere as well. So that's 3 cosine phi. And then I'm going to have 1 over root 2 equals the cosine of phi, which happens when my angle is pi over 4. So that's where it's intersecting the cone at the top. At the bottom, we know that z is going to equal 0. So z equals 0 means that 3 cosine of phi equals 0, which means that phi must be pi over 2. Okay, I think I have all my information set up. It's time now to actually go ahead and find the volume. Well, we know that the volume of a solid is that triple integral over your solid of dv. But I want to use the spherical coordinates. So we'll have a triple integral, but our integrand is going to be rho squared sine phi d rho, d phi, d theta. Okay, so our inside integral deals with rho, so I need to use my limits of integration or find my limits of integration. And I know that I'm going from 0 to 3 because my sphere has radius 3. The next set of limits of integration need to apply to phi. Well, I know that that cone intersects the sphere at pi over 4 and pi over 2. So my limits of integration here will be from pi over 4 to pi over 2. And finally, theta, to get the whole way around that sphere, I'm going to be going from 0 to 2 pi. Okay, now I'm ready for the inside integral. So I'll have the integral from 0 to 2 pi, the integral from pi over 4 to pi over 2. Integrating with respect to rho, I'm going to treat phi like it's a constant, which means the sine of phi is a constant as well. So the integral is just going to be rho cubed all over 3 times the sine of phi. We'll evaluate that from 0 to 3, and I still have d phi d theta. Plugging in my upper and lower limits, I've got the integral from 0 to 2 pi, the integral from pi over 4 to pi over 2. Plugging in the upper limit, I'll have 27 over 3, which is 9 sine phi. And when I plug a 0 in, I just get 0. So 9 sine phi d phi d theta. Now I'm ready for my next integral. So I'll be integrating with respect to phi. So I've got the integral from 0 to 2 pi. 9 is a constant. I pulled that out. The integral of sine is negative cosine. So I'll have a minus 9 cosine phi evaluated from pi over 4 to pi over 2 d theta. Plugging in the upper limit, I'm going to have minus 9 cosine of pi over 2, and then I need to subtract a minus 9 cosine of pi over 4. And I still need to do an integration with respect to theta. All right, so let's evaluate this. I've got the integral from 0 to 2 pi. So the cosine of pi over 2 is 0. This term is completely canceled out, and I'm going to end up with 9 times the cosine of pi over 4. The cosine of pi over 4 is 1 over root 2. So this is 1 over the square root of 2. And then it's still d theta. Okay, we need to bring this up because we need to do one more integration problem. I'm integrating the constant 9 over the square root of 2 d theta. So that'll be 9 over root 2 theta evaluated from 0 to 2 pi. So I've got 9 over the square root of 2 times 2 pi minus 9 over root 2 times 0, which is 0. So I've got 18 pi all over the square root of 2. If you prefer, you can rationalize your answer by multiplying by root 2 all over root 2, which will give you 18 root 2 pi over 2, or 9 root 2 pi. Remember, we're evaluating a volume, and so 9 square root of 2 pi cubic units. I hope that was helpful. Thanks.